Spike template triggering do's and don'ts. A Spike template dialog will open with Analysis, New WaveMark on an existing file, or automatically if a WaveMark channel is being sampled. In offline mode, I'm going to remove any existing templates using the trash can button. Individual templates can also be deleted in a similar way. By dragging the x-axis of the oscilloscope view, I can increase or decrease the number of data points to store for each WaveMark. The maximum number of data points online is 126. Offline, this is 1000 points. The maximum time range depends on the channel sample rate. Pressing play on the VCR type controls will rerun the data and allows us to set suitable trigger levels. Only data that triggers will be captured, so it is vital that the trigger thresholds are low enough to capture all spikes but high enough to ignore noise. Changing the threshold level, you can see that there are probably 3 spikes, the largest of which is triggering on the lower threshold. There can be cases when a spike class triggers on both the upper and lower thresholds due to slight amplitude variations. The same spike class then appears to jump between the 2 triggers, making it harder to treat as one unit. Moving the lower level further away from the spikes will remedy this. You can also right-click a trigger level and choose Move Away. Dragging the x-axis to show more time. If we zoom out too far, the spike on the right will not be captured as an independent event, as it exists in the same time window as the triggered spike. Triggering only resets at the right-hand edge of the view. You should reduce the x-axis range to approximately that of the spike width. This will reduce the number of data points captured per spike and stop spikes from being undetected. The data written to disk as a WaveMark is the full width of the oscilloscope view. This is different from the area used for templating. Moving the arrowheads at the top of the view changes the area of the Spike2 template. A display of the template width and the number of data points for the whole WaveMark and pre-trigger area is shown here. In addition to threshold crossing, there is also an amplitude window function. Any spike that passes the arming level but does not exceed the outer level will be captured. All others will be ignored. This requires 4 cursors, 2 above and 2 below 0. Right-clicking on one of the trigger levels opens a drop-down list. We can set the amplitude of a cursor by entering a value, copy the current value, or move cursors away so that they are inactive. We can fetch cursors, and we can link the WaveMark cursors to the data file time view. Cursor 1 is now linked to the lower trigger, and cursor 2 to the upper trigger. With the amplitude window enabled, the outer amplitude limits are linked to cursor 3, below 0, and cursor 4, above. If your offline waveform contains a DC offset, then the cursor positions will not be reflected correctly. Use the DC remove function by right-clicking on the data channel and choosing Channel Process to correct this. Enabling Make Templates now, and you can see the lower grey boxes populated with examples of spike classes that have been detected. Dragging the upper trigger towards the baseline, I can force more events to trigger. The meter on the right shows a degree of red, indicating that the system is considering many more provisional spikes. These are spikes which have not been allocated a template, and therefore it is a good visual guide to how well the matching is performing. A large amount of activity in the meter bar suggests we should consider repositioning the trigger levels and/or changing the template parameter settings. These settings determine how well a spike must match before it is considered the same class. That is it for many of the triggering do's and don'ts. We will revisit some of these in the future when investigating other aspects of spike template matching.